we're talking about maximizations. Maximization problems, okay? So we're going to design something, put it together, and then ask ourselves, how can we make the possible largest box out of the information we have, okay? So example 1, okay, a box without a top can be made by cutting square corners out, then folding it up, okay? That's this one here, right? We're going to do this one here, okay? If a rectangular piece of paper is 12 by 18 inches, is cut to create this box, find the dimensions and volume of the largest box. Then we'll also look at the domains. So what I do normally when I do this, I start with a picture, okay? So I'm just going to draw a picture. I always start with a picture. It just makes it easier, okay? Step 1 for me, draw a picture, okay? 12 by 18, right? So let's at least go there. And then I'm going to cut out the square corners, because if I don't cut out the square corners, I can't fold it up to make it a box. So I'm going to just visually make my cuts. They have to be square corners in order for this to make a box. Again, we're looking for the best box, so the size of cut we're going to say is unknown. We don't know how big the cuts we want, so let's call it X, okay? So we're going to cut. So this length of cut is X. Now if we cut these out and put the box together three-dimensionally, it looks like this. And again, hopefully you know how to draw a three-dimensional box. If you don't worry about it. Do your best, right? So let's label this box. Now I do know the height of the box is X, because that folds up, right? We saw that. This just folds right up to our height, right? Folds up, that's our height, our box. This length was 18, but we cut out the two pieces, so this length is now 18 minus 2x, right? This length was 12, but we cut out the 2x's, so now it's 12 minus 2x. Okay, so far so good, right? So what we want to do is make a volume of this box with respect to x. We're going to go v of x, which is the volume with respect to x, is equal to, length times width times height. So I'll go x times 12 minus 2x times 18 minus 2x. Okay, there you go. Now, Marie made a good statement. She goes, well, now we can multiply it all out. And I said, no, let's not do that, okay? You absolutely can multiply it all out. But the calculator can take it this form. Now, we're not going to use the negative b over 2. We're not going to use negative b over 2a because it's not a quadratic. If it's an x squared equation, you can use the negative b over 2a. We in pre-calculus don't have a technique for doing this. In calculus, you will. So for us, we're just going to graph it, okay? So we want to maximize, right? We're going to try and make the largest box. So let's graph this. So I'm going to take my calculator, y equals, and I'm going to go my x times my 12 minus my 2x times my 18 minus 2x. And before I do anything, I'm going to look at my window and use a little common sense, okay? So common sense, x min, probably 0 to, well, the biggest cut I can make, think about this. The biggest cut I can make is 12. Do you agree with that?
Yeah.
Biggest cut I can make is 12. So is 6. So I'll just make this 6. You okay with that? Because if I go 6 and 6, the box is gone, right? So the largest x value has to be 6. I'm doing volume, so I don't know if I go 18 times 12. What's 18 times 12, Marie? You got a calculator handy. So I'm thinking volume, 18 times 12. 216. So let's make this about maybe 220. And if I need to make it bigger, I will, okay? But I'm just trying to get an idea of what to graph, okay? So let's graph this, okay? Okay, I need to go a little bit bigger, don't I? Okay, do you want me to go back to my window? Yeah, there's my window. So 220 didn't quite make it, so I need...
240 works.
Okay, we'll go to 240. Marie says 240, okay? So let's make our window 240 so we can see a little bit more of it, all right? And then I graph it. And, all right, there it is. So there's my maximum. So at this maximum value, we get the best cut, don't we? To give us the largest volume, because V is the Y and X is the cut, right? So I'll go second, calculate my maximum. Go left bound, right. Right bound, right. How am I doing? Good? Enter, and you guys know how to do this, of course. Guess. So according to my calculator, the best cut is when x is about 2.35. That gives us a volume of about 228.16. And that would be in terms of inches cubed and in terms of inches, okay? So if we're going to make this box the biggest we can, we're going to make our cuts 2.35 inches. That'll give us a volume of 228. Any other dimension would make a smaller box. Any other size cut would give us a smaller box. Okay, if you make it too big, you lose volume. If you make it too small, you lose volume, okay? Now, the domain. So the domain is the x, right? The domain. Let's talk about the domain. So we know domain is all possible x values. But in this case, Carmen, the domain happens to do with the cut. So if we're going to build this box right here, what's the smallest cut I can make? 0. Well, almost 0, right? Smallest could be 0. It wouldn't be a very tall box, right? But the smallest could be up to 0. And the biggest we could cut is 6, because if I cut more than 6, in fact, there's a few. Nathan, I gave you one of these, didn't I? Remember I gave you a box?
He had 5, and 5 still didn't work.
Right, so I gave you guys boxes where if you cut too much, your box disappears, right? So the largest your cut can be is up to 6, right? And there's your domain, okay? Thumbs up. That one's not too bad. Not too bad. Thumbs sideways. All right, okay. Let's go on to example 2. So a rectangular piece of paper can be rolled into a cylinder. Okay, without bases, it's not going to have a top or bottom, right? It's just going to be, right? It's just a regular piece of paper, right? If the paper has a perimeter of 100 centimeters. Now, you got to be careful on this because, you know, this piece of paper, if we could redo it, we could stretch it. You with me? We could stretch it or pull it. As long as we keep the perimeter at 100, we could change, we could stretch it, pull it, or whatever, but we could change, don't change the perimeter, okay? So we can make this thing look in all sorts of different shapes, okay? So find the dimensions of the paper that would maximize the volume, okay? So first of all, start with a picture, okay? So when I start with a picture, I'm going to start with a piece of paper. And it's a rectangle, right? So let's call this X and this X, right? Because these two sides we don't know. Now, if it's 100 centimeters, then if I take my 100 and I use up some here and I use up some here, we'd have minus 2x left over, right? To put on both sides. But because we've got to put them on both sides, we're going to divide by this 2, so you can put half of what's left over on this side and half of what's left over on this side. So we're really going to put a 50 minus x here and a 50 minus x here, okay? So far, so good, right? Now, let's roll it up. Let's roll it up. Maria, let me know if I'm off the paper, okay? The height of the cylinder is definitely 50 minus x, right? What I'd like to find is the radius. So the circumference is x. I know that because the x is here. I mean, the x is there, right? The x is all the way across, but I roll it together, it's the circumference, right? Circumference around this thing is this value here. Okay, that's the circumference is x, going all the way around. That's not the radius, and I need the radius because the volume of a cylinder is pi r squared h. Okay? All right, so now I know the height. I know the height. Here's my height, 50 minus x. I just don't know the radius. But I do know something about a circumference. One of the things I know from geometry is the circumference of any circle is equal to c is equal to 2 pi r, okay? So now we need a second equation in here, okay? So if the circumference is x, we could solve for r and get everything in terms of x. We have to get it in terms of x because we need to graph it, right? You can't graph this thing in terms of x's and r's. In fact, you can't even get an r in this thing, can you? So we need to somehow get our full formula in terms of x's. So if the circumference is x, we've got 2 pi r, let's solve for r. So r would be equal to x divided by 2 pi, okay? You with me? Just divided by 2 pi. So here's my radius. Here's my height. Let's plug it in the formula, okay? So now I'm going to go v of x, volume with respect to the x, because it is all in terms of x, is going to equal pi times the radius squared. Now this is the radius. The radius is x over 2 pi. Squared times the height, which is 50 minus x. Okay, now we could put this in our calculator. We could. If we're going to put it on our calculator exactly the way it is, we got to make sure you put another set of parentheses here, okay? I'm going to simplify this to make it easier to put in the calculator, okay? But you can put it in the calculator if you just make sure you put an extra set of parentheses here. So you divide this whole thing by 2 pi, okay? I'm going to simplify it so it makes it easier to put in. If I do a little simplification, I'll go v of x is equal to pi times x squared over 4 pi squared times 50 minus x. Okay, so I squared the x and I squared the 2 pi. When I square the 2 pi, I get a 4 pi squared. Okay, so I'm simplifying this. I'm going to make it an x squared and a 4 pi squared. Yeah, it's hard. I'm going to do one more simplification. I see a pi and a pi squared, right? I see a pi and a pi squared. So let's cancel a pi for pi. And so another version of this would be v of x would equal x squared, okay, times my 50 minus x divided by 4 pi, all right? I can put that in my calculator. I am going to use parentheses here. Again, I want to reiterate that you could have put it in your calculator here, but it's a little bit easier to type it in your calculator down here in this form, okay? So if I want to maximize it, let's take a look at it, right? So let's go to my y equals, clear that out. Let's go x squared, parentheses, 50 minus x, parentheses, divided by parentheses 4 pi parentheses. Okay, so go ahead and put it in your calculator. Okay, can you guys see that? Window. Okay, if I go to my window, my domain is 0 to 50. So I've got to go from 0 to 50 because I know if I go 50-50, I've used all my paper. So the biggest, each side could be 50-50, but then you wouldn't have anything put there. The volume, Marie, you got your calculator handy? Let's see, just try 50 times 50. Well, that's 2,500, isn't it? Yeah, 2,500, and I could be off. I'm just trying to take a guess at my window, all right? I just went the 50 times 50 to see what happens, because remember I told you the square. Okay, if I graph it, let's see what I get. All right, not bad. Okay, so we got it. So now let's find out how big to make this size so we can build our cylinder. So we go to second calculate, our maximum, enter, left bound, yeah, that'll work, right bound, I guess. So I get about 33 1/3, right? So the value we need for our x value is 33 1/3. Okay, and centimeters. Okay, and then the height would be, if I were the engineer and I want to send it to the machinist, I would need to tell the machinist the dimensions, right? People do this in the real world, by the way. Smart people like us do the math. We send it to people that are machinists, and they make the thing. So If I go 50 minus 33 and 1/3, what's that, a 16 and 2/3? Probably 50 minus 33. Yeah, 16 and 2/3. So the height should be 16 and 2/3. The length of this, so we can take our rectangle, when we make our rectangle, we're going to make our rectangle this size. We're going to say make it so that this is 33 and 1/3, and this is 16 and 2/3, which makes a jelly roll, doesn't it? It really does make the jelly roll instead of the burrito, because this is much wider than this. Sideways? Any thumbs down? Okay. All right. Will's sideways, so I'm not going to work hard. Okay. All right. Turn it over. Zane, how you doing? So the domain. What do you guys think the domain should be? What is the domain? How about 50? Now why 50? It's like this. You have, right, you got 100, right? You could put all 50 here and all 50 here, right? It would work, except you wouldn't have any height, correct? You could put all of your paper here and here, 50, 50. You wouldn't have anything left. Now that would be about the worst one to make. But all the domain says is, what are all the possible ways to make this? Everything from 0 to 50 and everything in between, right? The one we really want to make is where it's 33 and 1/3 though, right? All right, ready to turn the page? All right. Here we go, our equilateral triangle, right? So we're going to take this box, we're going to fold it up, we're going to make, say it again for me, Lane, what's it called again? A Toblerone? Toblerone, I don't know what it's called. Anyway, that kind of box, right, for that kind of chocolate? So let's take and let's look at picture, okay? Here's our picture. So in order to make it, we're going to make a fold here and a fold here, right? So we're going to take this piece of paper, right? We're going to fold it here. We're going to fold it there, right? How big is each fold? Well, they have to be equal, right? So let's make this X, 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 right? This is also X, X, and X, right? Because we're talking about perimeter, so when we find out what's left over, we're going to put some of our perimeter here and the other part of our perimeter here, and what's left over would go on the sides, right? So we've got our 80 centimeters that we need to spread around the whole thing, right? Minus 6x, okay? But we have to put half of that here and half of that here, so we better take what we have and divide it in two so we can put half of it here and half of it here. So I'll have a 40 minus 3x. So I'll put this as a 40 minus 3x, and this is a 40 minus 3x, okay? So I had to fold, 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 fold. So I got all my 6x's here. From the 80, I took away those 6x's so I can put what's left over on the sides. That was my 80 minus 2, my 6x. But I had to divide it in half because I had to put half of what was left over here and the other half of what was left over here, okay? So that's why I divided by 2 and got 40 minus 3x. Now, what's the value of x? Well, I don't know. Well, let's try and figure it out. Now, volume. So let's figure out what the volume of this thing is. Okay, the volume of this thing, if I fold it all up, make it into its little box, its Tobler box, or whatever you guys want to call it, Toblerone, I don't know. X, 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 right? Let me think about it. If I fold that up, there's my X, 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 right? The length is 40 minus 3x, okay? Now, if you got to go back to geometry and remember how you find the volume of this prism, okay? It is a prism. So the volume of a prism is just going to be the area of its base times its length. Okay? So the volume of this prism is going to be the area of its base times its length, right? Now the length, we know. The length is just your 40 minus 3x. And the base, we did. Theory of the base is our x squared root of 3 over 4. That's why we did this, right? We found the area of this thing, didn't we, in our warm-up, which turned out to be x squared root of 3 over 4, right? So our area of base is going to be an x squared root of 3 over 4. Okay, now, if I simplify this a little bit, this would probably help us put it in our calculator, okay? So what I would do to make it a little bit easier is I would just make it v of x equals, I'll go parentheses x squared root of 3, or I might even put the square root of 3 first, sorry, oops, sorry, good thing I use a pencil, huh? It might be easier to just go square root of 3 x squared times my 40 minus my 3x, okay? Divided by 4. Okay, there's my volume. There's my volume. Okay, so I just have my, I just switched around. I went square root of 3x squared times my length divided by 4. Okay, now let's put that in my calculator, okay? So let's see, how are we going to put this in our calculator? Just carefully, huh? So clear, clear, let's go parentheses. I'll go the square root of 3 x squared, okay? Parentheses 40 minus 3x divided by 4, okay? I'll let you put that in your calculator, okay? Okay, window, oh boy, you know what? I've got 80, what's 80 divided by 6? Because that's the biggest x can be. If I put all my pieces here, what's 80 divided by 6 for my window?
13.33.
So if I go 0 to say 15, it'll fit, right? And then volume, let's see, 40 times 40 is maybe 1600. It's not,
Times 40.
no, 40 times 40, I'm thinking. I don't even think it's going to be that big, 1600. I doubt it. But again, remember on our window, if we don't find it, we fix it. If we need to go bigger, we go bigger. If we need to go smaller, we go smaller. I just throw out guesses that I think are reasonable guesses, and then I play around with it. Okay, let's just graph it. Well, okay, that was a reasonable guess, wasn't it? And let's go to second calculate. Maximum, right? Left bound. Right bound, guess. Alright, so here's what we need to do. X has got to be about 8.9 about. 8.9 for each of these folds, alright? And then the volume of that should be 456.2 possibly. That's in terms of centimeters squared. So if I go back to my paper, right, I need to make each of these 8.9, 8.9, 8.9. Fold all together. What's the length of this thing? Well, let's figure it out. The length of this thing comes from here, right? Isn't that the length? That's my length. So let's see, I'd go for the length. I'd go my 40 minus 3 times 8.9. I don't know. 40 minus 3 times 8.9. About 13.3, okay? So I would take it to the shop. And I'd tell the guys in the shop, make it 8.9, 8.9, 8.9, and make this 13.3. Because when you fold it together, you're going to make my biggest box. How big of a box? 456.2 centimeters cubed. Any other variation of this, whether you make these bigger or smaller, gives me a smaller volume, okay? Thumbs up, sideways, down. Okay, so if we practice this, and I don't mind helping you with your homework today, maybe you want to, anyway, let me pass it out and we'll see how you do, okay? And then if you need help, I can help you.
What would the domain be?
Oh, domain, yes. What is the domain? Thank you. What's the domain?
0 and then 40.
80 divided by 6. Where did I get 80 divided by 6? If I use all of my perimeter here, I wouldn't have much left here, would I? So what is 40 divided by 6? I don't know, let's see, that would be 80 divided by 3, 40 divided by 3.
13.33.
Yeah. 13 and 1/3. There we go. Okay, there's my domain. Okay. And did I hit stop yet on this thing?